Good morning, class 1B. Today, inshallah, we'll start Unit 3. Okay, Unit 3 is talking about solutions, acids, and bases. In the first part, Lesson 1, we'll talk about solutions. Okay, first, solutions are considered as a type of mixtures. Okay, what is mixtures or what is a mixture? A mixture when we mix two or more substances, okay, but they don't react chemically. They don't chemically combine with each other. They are just mixed together, okay? And these mixtures can be classified into two types. Mixtures can be homogeneous mixtures, okay, which includes solutions, or heterogeneous mixtures, which includes colloids or suspensions, okay? Homogeneous mixtures like solutions, for example, if we place a spoon of salt in water, okay, and stir well, what do we notice? We will notice that the salt cannot appear in the solution, cannot be seen as a solid salt, okay, but it disappears, it dissolves in the water, okay, so forming a solution, a homogeneous solution, okay, where the particles of the salt are found in each part of the water equally, okay, so equal amounts of salt are found in the whole solution. So that's why it's called homogeneous mixture. While heterogeneous mixture, if we put some sand, for example, in water, okay, the sand just precipitates in the bottom of the flask, okay, it does not dissolve in water, so that's why it's called a heterogeneous mixture and called a suspension. Okay, about solutions. Solutions consists of two components. The minor one with lower ratio is called the solute, like sugar, for example, and the major one with higher ratio is called the solvent, like water, okay? The produced homogeneous mixture of two or more unreacted substances, this is called the solution, which is the mixture between sugar and water, okay, forming a sugar solution. Okay, that's how we can see, okay, the formation of solution by placing some solute, stirring, and it's gone, okay? They form a solution where the solute can no longer be seen by the naked eye. So solutions can be classified into different types according to three main points. The first point is the physical state of the solvent, okay? Like we can have gaseous solutions if the solvent is gas, or liquid solutions if the solvent is liquid, or solid solutions if the solvent is solid. And here are some examples. Like a gaseous solution, if the solute is a gas and the solvent is a gas, this is like air, okay? The air around us, it consists of different gases, okay, and they're all mixed equally, okay? For liquid solutions, we can have gas dissolved in liquid, like soft drinks, okay, or oxygen dissolved in water, oxygenated water, or liquid dissolved in liquid, like alcohol in water, or ethylene glycol in water, and it's another type of alcohol also, okay, or solid in liquid like sugar or salt in water. Okay, for solid solutions, we can have a gas in solid solution like hydrogen in platinum or palladium, and the hydrogen dissolves in platinum or the palladium in a way that resembles the sponge, like how sponge is able to absorb water, okay? So some metals like platinum or palladium is able to absorb hydrogen gas, so this is how it dissolves. We have liquid in solid solutions like silver amalgam, okay, and silver amalgam is formed by dissolving some mercury in silver, okay, or in a metal, and it's used often by dentists, okay? This amalgam is used to fill the cavities between our tooth. Okay, and we have solid in solid solutions like alloys, like any alloy made of two or more solid substances. Okay, this is a solid in solid solution. Okay, we need to remember now that water is a polar compound, okay, and it's considered as a polar solvent as well because it had the ability to dissolve a lot of polar compounds. Okay, and we already know that the bonds between the oxygen and the hydrogen is a polar covalent bond. This is because the oxygen has higher electronegativity than hydrogen. So these bonds are polar and the angle between them is 104.5. So let's talk about the second main point, which is the ability to conduct electricity. Some solutions have the ability to conduct electricity and some other solutions don't. So first solutions that conduct electricity we call it electrolytic solutions or electrolytes, and we have non-electrolytic solutions or non-electrolytes. So if we talk first about electrolytes, they are substances whose solutions or moltens can conduct electricity by their free-moving ions. Okay, so they are substances when we make a solution or when we melt this substance, it can conduct electricity due to the presence of free-moving ions. Okay, and electrolytes can be strong electrolytes or weak electrolytes. Okay, we said that the solutions conduct electricity by the free-moving ions. So the conductivity of electricity depends on the free-moving ions. So we conclude that strong electrolytes are electrolytes that have large number of ions, but weak electrolytes are electrolytes that have low number of ions. Okay, we can see in this picture that if we test the electrical conductivity of a solution, we can find if the lamp does not illuminate at all, this indicates that this solution is a non-electrolyte, which indicates also that it has no ions at all. But if the lamp illuminates, this indicates that the solution contains ions. But if the illumination is weak, this indicates the presence of weak electrolytes having a few number of ions. And if the illumination is strong, this indicates a strong electrolyte with many ions present. So strong electrolytes are substances which are completely ionized, which means that their molecules are all ionized and all dissociates into ions. Okay, so it conducts electricity strongly, such as ionic compounds like sodium hydroxide, sodium chloride, and some polar covalent compounds such as hydrogen chloride. Okay, and hydrogen chloride as a gas, it doesn't conduct electricity because we sure know that as a gas hydrogen chloride has no free moving ions, but when it dissolves in water forming hydrochloric acid, okay, which means that this hydrogen chloride dissolves in water forming hydronium ion and chloride ions. Okay, the presence of ions here makes the hydrochloric acid a good conductor of electricity. Okay, and the formation of H3O positive, which is called hydronium ion, is due to the binding of hydrogen proton H positive of HCl with water H2O forming a hydronium ion. Okay, and second, we have weak electrolytes, and they are substances that are only partially ionized. A part of them is ionized, dissociates into ions, and it conducts electricity but weaker than strong electrolytes, of course, because weak electrolytes here have less number of ions. Okay, some examples like polar covalent compounds such as ammonium hydroxide, such as acetic acid, such as water itself, they are all considered as weak electrolytes. Okay, if we talk about non-electrolytes, so they are substances whose solutions or moltens do not conduct electricity at all due to the absence of free-moving ions. And these are such as sugar and alcohol. Okay. The third point is the degree of saturation. If we prepare a solution, the solution can be unsaturated or saturated or super saturated. Okay, unsaturated solution means that this solution can still accept more amount of solute at a certain temperature. If we measure the solubility at a certain temperature, okay, if we add a spoon of sugar to a cup of water, okay, it forms an unsaturated solution, because if you add another spoon of sugar or another amount of sugar, okay, it can still dissolve in the solvent, in the water. Okay, so this is called unsaturated solution. Okay, if the solution cannot accept any more amount of solute, so it's called saturated solution. So the solution here contains maximum amount of solute at a certain temperature. So what's a supersaturated solution? A supersaturated solution is when we have a saturated solution but it accepts more amount of solute. So how can a saturated solution accept more amount of solute? By heating a saturated solution. Okay, by heating the water molecules, we know that the intermolecular forces between water molecules gets weaker, so the intermolecular spaces gets wider, so the water here or the solution can accept more amount of solute. Okay, so by heating a saturated solution and adding more amount of solute, we can obtain a supersaturated solution. And then of course, to return it back to a saturated solution from a supersaturated, we can cool the supersaturated solution so that the excess solute is percepted, or by the crystallization method, and it's done by placing a small crystal of the solute in the solution and the excess of solute molecules precipitate on its surface. Okay, now we'll talk about the dissolving process. How does the dissolving process occur? It's the process that occurs when the solute dissociates into positive and negative ions or into separated polar molecules. Okay, it's the process when the solute dissociates either into positive and negative ions or into separated polar molecules. Each of them binds to the molecules of the solvent. And since water molecules are in continuous motion due to their kinetic energy, so when placing a crystal of sodium chloride as a solute, for example, the first thing that happens is that polar water molecules collide with sodium chloride crystals. Then water molecules start to attract the ions of sodium chloride, sodium ions and chloride ions, by directing the suitable pole towards each of them until these ions are isolated completely. Okay, the positive ions are isolated from the negative ones and they are prevented from binding again. Okay, just like this, the water molecules arrange themselves so that the positive hydrogen is attached or facing towards the chloride negative ions, and the oxygen negative ion facing the sodium positive ion. So that's how we can attract the ions away from each other and isolate them. Okay, the speed of this process depends on the surface area of the solute, okay, the stirring process and the temperature. Okay, about concentration, the ratio of the amount of solute to that of solvent affects the concentration of solution. What does that mean? It means that if the amount of solute is relatively large or near the amount of solvent, approaches the amount of solvent, so it's said to be a concentrated solution. So it has large amount of solute. Okay, and a diluted solution is the solution in which the amount of solute is so small compared to the amount of solvent. Okay, so by adding more solvent, the concentrated solution is converted into diluted solution, and by adding more solute, a diluted solution is converted into a concentrated one. Okay, we can express concentration by three methods. First, either by percentage or by molarity or by molality. First, we start by percentage. The percentage is used by two methods. First, we can use the percentage by mass percentage. Okay, it's the mass of solute in 100 grams of solution. So we can see, or we can calculate the mass of the solute that's present in 100 grams of the solution times by 100. Okay, and this is the mass percentage, and of course the mass of the solution is the sum of the mass of the solute and plus the mass of the solvent. Okay, so let's see an example. Calculate the mass percentage from dissolving 10 grams of sucrose in 240 grams of water. First, we have 10 grams of sucrose, which is the solute, 240 grams of water, which is the solvent. So the solution mass is the sum of both masses, solute and solvent. So solution mass is 250 grams. Now we can calculate the mass percentage by dividing 10 over 250 times 100. So the mass percentage of this solution is 4%. Okay. The second thing, we have volume percentage, and it's the volume of solute in 100 milliliters of solution. So it's the same percentage but measured in volume and not mass. Okay. And don't forget that the density of water is 1 gram per milliliter, which means that if water is given in mass or in volume, we can convert it from mass to volume or from volume to mass, because we have the density of water equals 1 gram per milliliter. So calculate the volume percentage of solution formed from addition of 25 milliliters of ethanol to 25 grams of water. This means that we also have 25 milliliters of water. So we converted the mass of water into volume. Okay, now we can calculate the volume of the solution by the summation of both the volumes of ethanol and water, and calculate the percentage 25 over 50 times 100. So the volume percentage here of the solution equals 50%. Okay, the second method we have is the molarity, and the molarity is the number of moles of the solute dissolved in 1 liter of solution. Its unit is molar or mole per liter, which is indicated by a capital M letter. Okay, this is molarity. So molarity is the number of moles of the solute over the volume of the solution. So the third method we have is molality, and the molality is the number of moles of the solute dissolved but in 1 kilogram of solvent. It's not the number of moles in or divided by volume. Okay, no, it's the number of moles divided by the mass, and the mass of solvent, not the mass of the solution. And this is molality. Its unit is molal by a small letter m, or mole per kilogram. Okay, now let's see some problems. Calculate the molar concentration of the solution resulted from dissolving 85.5 grams of sugar in water to form a solution whose volume is 0.5 liter. So we're asked to calculate the molar concentration. We have the mass of sugar and we have the volume of the solution. Now we know that the molarity can be calculated by dividing the number of moles of solute over the volume of the solution. Okay, but here we don't have the number of moles. So let's remember in unit 2 we've learned that the number of moles can be easily calculated by dividing the mass over the molar mass. So we can calculate the molar mass of sugar, okay, which is 12 carbon atoms plus 22 hydrogen atoms plus 11 oxygen atoms multiplied by each atomic mass, of course. Okay, by dividing 85.5, which is the mass, we can find that the number of moles of sugar is 0.25 mole, and by dividing that to the volume of the solution, which is 0.5 liter, we can conclude that the concentration is 0.5 molar solution. Okay. We'll have another problem for the molality. Calculate the molality of a solution prepared by dissolving 20 grams of sodium hydroxide in 800 grams of water. Okay, now we have the molality. We're asked to calculate the molality of a solution, and we know that the molality is the number of moles per or in over the mass of the solvent. Okay, so we need to find the mass of the solvent. It's given equals 800 grams of water, but it's divided by 1000 because we all know that the mass of the solvent is measured in kilograms and not in grams. Okay, so we have the mass of the solvent equals 0.8 kilogram, and we have the mass of the solute, but we need the number of moles, so we'll divide the mass of the solute by the molar mass. We can find that the number of moles equals 0.5, so by dividing 0.5 over 0.8, the molality here equals 0.625 mole. Okay, and that's enough for today. Thank you.